Hi everyone, welcome back to Science 9. This week in electricity, we're going to be going over the basic parts of electric circuits and then some simple Ohm's law calculations. So just a reminder what the big ideas are for electricity. Electric current is the flow of electric charge. What we're going to focus on this week is how voltage, current, and resistance are related using Ohm's law calculations. And then we're also going to go over the basic parts of a circuit. And then next week, we're going to go over the specific types of circuits. And just further to what I just said, this week, we're going to focus on circuits. So what makes it complete and how electricity flows through the circuit. And some how these three, voltage, current, and resistance, how they're related. So in order for electricity to flow, you need a complete circuit. It needs to be connected the whole way through. So the three things you need for a circuit, you need a source of energy. So you need a source of voltage. Usually it's a battery, a wall outlet, electrochemical cell. Second thing you need is conducting wire. Well, a conductor, usually it's wire, but it can be other things like metals. So wire that lets electricity flow through it. And then the third thing you need is a load or a resistor, something that slows down the electricity and it turns it to a different form of energy. And a lot of electric circuits have switches in them. You don't need a switch, it's optional, but most circuits, especially all the circuits in your house, circuits and devices you have that you could turn on and off, they have switches in them, but those are optional. So here we see a basic circuit. The battery is the source of electricity. There's conducting wires, and then there's a load or a resistor. So the electricity flows through this buzzer, and when it's on, it turns it into sound energy. Now, a lot of times electric circuits, they're compared to other things. In your textbook on page 281, it's compared to a kid going around a water slide. Basically, the battery is anything that raises the potential energy of these little objects that are moving throughout this circuit. And these little objects are electrons. Um, they should actually be negative, but this is just a comparison. When they go up, that's like they're gaining potential energy. And then when they fall back down, they are losing potential energy. And on this diagram here, when they fall down, they cause this, it's kind of like a water wheel to turn. And that's like electricity going through, say, a speaker. And the energy is converted from electrical energy to sound energy. So electric circuits, when they're drawn on paper, we use symbols for certain things. And those symbols can be put together to make full circuit diagrams. So here are the symbols you're going to need to know. Just a straight line, that's just a conducting wire. This V with a circle around it is the symbol for a voltmeter to measure the voltage. These symbols right here, so a longer line is the plus sign and a smaller line the negative sign, and then wires attached to it, that's a cell and or a battery, because a battery is just a couple cells put together. Here's a symbol for a light bulb, and then a switch. There's two dots when the switch is open, so when the circuit is off, because it's not connected, the switch is open like this, and when the switch is on, it's closed, so the full circuit is connected. So here's some examples of these symbols being combined to make circuit diagrams. So here's a picture of like a real life circuit. So there's a battery, wire comes out, goes through a light bulb. There's a switch in the circuit. In this case, the switch is open. And then from the other side of the switch, the wire goes back into the battery. We would have built these in real life. Had we been back in school, we have all the equipment to make these simple circuits, and we still might at the end of the year. But here it is representing a circuit diagram. So there's a battery, switch is open, wires go through the light bulb and return to the battery. So there's one example of a switch, sorry, of a circuit with an open switch. Here's an example of a circuit with a closed switch, so it's on, and just shows you the difference here. So there's the power source of the battery, wires go through the switch, which is closed, come out of the switch, go through the light bulb, and then back to the battery. Here's another example with two light bulbs now. We're going to get into these circuits next week, but to draw it, it's just battery, wire, light bulb, wire, light bulb, wire, switch, goes back to the battery. And ammeters and voltmeters, they could also be added to the circuit diagrams because oftentimes they're added to circuits to see what the voltage or what the current is. And again, we're going to do this in school, but next week when we do this, there's a virtual lab we could do online that we're going to do with this. So ammeters are in the circuit, so wires come out of the battery, go through the ammeters. Voltmeters have to be connected around what we're measuring. So if we're measuring how many volts are used in this light bulb, we would attach a clip to one side, to the wire on one side, and the wire on the other side. And it would tell us how many volts go through the light bulb, but this is how you add ammeters and voltmeters to circuits. So ammeters, like we've talked about last week, have the symbol A, voltmeters have the symbol V. So I'd like you guys to pause here and click on this link. And this link is pretty cool because it lets you build your own circuits, electric circuits here, this FET simulation. So we're just gonna start with a simple one. It's just drag and drop. We'll drag this battery over here. Wire connects to the battery. We'll have a wire going down. We're going to put a switch in here. Another wire. We'll add a light bulb. Another wire. A wire going up. And then finishing off the circuit. And you notice nothing's happening right now, but as soon as we close the switch, just click on it, the electrons start flowing and the light bulb is lit up. And if we want to add certain things, if we want to see what the current is, we would add the current in here. Right now it's 0 because the switch is closed, but when the switch is open, in this case, the current is 0.9 amps. And then if we want to see the voltage here, we will attach the voltmeter to both sides of the light bulb. And we see that there's 9 volts of electricity going through this light bulb. And if we want to look at the battery, the volts on the battery are 9 volts. If we increase the voltage, now there's 10 volts going through the light bulb and the current goes up too. And I'm going to explain why that happens next. So as you just saw, when I changed the voltage on the battery, the current went up. And that's because voltage, current, and resistance are all related. So just remember the symbols. Symbol for voltage is V and the units are volts. The symbol for current is actually I and the units are in amps. And the symbol for resistance is R and those units are in ohms. So like I just mentioned, voltage, current, and resistance, they're all related. And you can calculate how changing one affects the other, or if you're given two values, like if you're given the resistance and the current, you could calculate the voltage using Ohm's law. So Ohm's law, to calculate the voltage, we go current times resistance. To calculate the resistance, we go the voltage divided by the current. And to calculate the current, we would go the voltage divided by the resistance. Now, sometimes this little triangle is used, and how this triangle is used is, say you want to find the voltage, you cover up volts, and then you just have I right beside R. So because they're beside each other, you go I times R. If you want to calculate the resistance, you cover up the R. V is on top of I, so we go V divided by I, which are basically just these three here. Some people prefer the triangle, some people prefer just having the formulas. So we'll do a couple practice problems here. So a circuit has a resistance of 10 ohms and a current of 10 amps. Calculate the voltage. So that is 100 volts, because we would go 10 times 10 to get 100 volts. Okay, for this next one, I'd like you to pause it here. So a circuit has a voltage of 10 volts and a current of 10 amps. Calculate the resistance. So pause here and check your answer. It's 1 ohm because we want 10 volts divided by 10 amps. And then same for this next one, a circuit has a resistance of 15 ohms and a voltage of 90 volts. Calculate the current. So pause here. And once you figure that out, we know it's 90 volts divided by 15 ohms, so it's 6 amps. Now, Ohm's law can be used in real life circuits to calculate the values we want to calculate. So we'll do a couple more practice problems. So calculate the voltage of the circuit if the resistance of the light bulb is 5 ohms and the current is 5 amps. So we could actually, I'll show you how to, oh, we can't do this one on the PhET simulator, but we could calculate it. We know to calculate voltage, we cover up V, so it's current times resistance. So it's 5 ohms times 5 amps, 25 volts. And we could check that on the PhET simulator here. So if we set the battery to 25 volts, and if we set the resistance of this light bulb to 5 ohms, you look at the current's 5 amps. If it was 6 ohms, the current would be different, but 6 times 4.17 still gives you 25. Okay, we have another one here. Calculate the current of the circuit if the resistance of the light bulb is 5 ohms and the voltage is 30 volts. So we want to find the current, so we cover up I, so it's voltage divided by resistance. So it's 30 divided by 5, which is 6 amps. And again, I'll show you that on the simulator here. We'll put this up to 30, and the resistance was 5 ohms. So we're going to change this to 5, and we see the current is 6 amps. Okay, and we'll try one more problem. So calculate the resistance of the light bulb if the current is 15 amps and the voltage is 60 volts. So we know we want to calculate the resistance. So we know we have to go voltage divided by current. So 60 divided by 15 equals 4 ohms. Okay, so I've put up these 2 extra help videos if you need any more help with this. This first one just explains an electric circuit and shows you some animations. And the second one is some Ohm's law calculations. So the assignment for this week, just because I'm asking you guys to draw things out for the first half of this, you have to draw 2 circuit diagrams right here. I'm just going to get you just to write out the answers on a blank piece of paper, take a picture of the paper, and then upload it as your assignment. Okay? That's it for today, guys. I hope you have a great week, and I will talk to you next week.